Welcome to Mrs. Benjamin's Geometry 3.5 video notes. Today we're going to talk about parallel lines and triangles. Our objective today is to use parallel lines to prove a theorem about triangles and to find measures of angles of triangles. Now you might want to think about parallel lines and triangles, and those really don't go together, but I'm going to show you how we're going to prove those angles that are inside the triangle with this. So our first example, or number one, we've got the sum of the angle of measures of a triangle is always the same, 180 degrees. And I think this is something that you might have already learned in math before, but the concept is I've got three angles inside this triangle, and any triangle has three angles. No matter what shape this triangle is, if I add angle 1, 2, and 3 together, they will always be 180 degrees. So kind of a cool little theorem, and I think something that you've already know. Postulate 3.2 says is the parallel postulate, and what that states is that through a point not on the line. So if I have this line right here, and I place a point just randomly off the line, there is only one line that I can draw parallel to that given line. That's what that states. So we're going to use this to prove our triangle theorem, our triangle sum theorem in just a moment, but it's also used in Euclidean geometry also. Okay, on the next page, Theorem 311 is the triangle angle sum theorem. And what that states is that, that's kind of the picture I did above, except they use letters, that angle A plus angle B plus angle C is 180 degrees. All right, in order to prove this triangle angle sum theorem, we need to draw what's called an auxiliary line. And this line is a line that you add to a diagram to help explain relationships and proofs. So on the next page, we have a red line in our example. So if you flip to the next page, we've got this red line in example 5 here, and it says proof of theorem 311, triangle angle sum theorem. So we're given this triangle ABC, and that's how you notate a triangle. So you name it with the 3 letters, and we need to prove that angle A plus angle 2 plus angle C equals 180 degrees. So we're going to prove that the sum of the interior angles here are 180 degrees. So what I have here is a proof, and I will show you the whole thing here. And what I'd like you to do is do a fill-in proof again like we did the day before. So we've got these angles, these statements and reasons. Go ahead and fill those in, maybe with a pen, and then in pencil go back and try your best and try to fill in the blanks. Go ahead and pause the video now. Okay, how did you do on that? I hope you tried your best. Not all of them were hard. Some of them were a little tricky, but all right. Number 1 was already put in for us, so it says draw PR through B parallel to A, and the reason behind that is called the parallel postulate. Okay. Now, step 2 says angle PBC and angle 3 are supplementary. So PBC, I'm just looking at PBC. What angle is that? Those are supplementary. So our reasoning is, get my pen here, and is angles that form a linear pair let me write out pair are supplementary. Okay. Now step 3 says the measure of PBC, I think I was supposed to have an angle in there. I left out my angle. The measure of angle PBC and angle measure of angle of 3 equals 180 degrees. And I just kept the reasoning there. It's definition of supplementary angles. Okay, so we're just kind of tying the supplementary part here, and then now we're putting that into the measuring. Okay, so now the measure, I did it again here, the measure of PBC equals angle 1 and angle 2. Well, why is that? And that's that one that we forget about a little bit, but that goes back to the angle addition postulate. Okay, remember when we add those angles together, it will add up to another set of angles. Okay, so the measure of PBC equals the measure of angle 1 and the measure of angle 2. Okay, number 5, now how do we go to the next step? We're going to use the substitution property somehow. So how can we substitute in what we've got? Well, we know that PBC equals this angle 1 and angle 2. So let's plug in for this PBC here. So the number 3 PBC, let's plug in the measure of angle 1 plus the measure of angle 2. Okay? And then we already had the measure of angle 3, right? So I'm going to put that in blue just so we can see it. So plus the measure of angle 3, right? And that's going to equal 180 degrees. Okay, so the PBC that we had is going to, the TBC that we had in 3 is going to become angle 1 and angle 2. Okay, and that was step 5, and so we use substitution there. Okay, so angle 1 is congruent to angle A, and angle 3 is congruent to angle C. Why is that? And we're going to call this if lines are parallel, which they are, and I should have done this in a different color, and I will in just a moment, then what are those? Those are alternate interior angles. So alternate interior angles are congruent. Okay, and I'm going to change this color. I'm not sure if it'll change on the video, though. Let's see if it does. I want to change it to orange, so let's see if that'll work on the video. Okay, all right, and then number 7, our reasoning is that congruent angles have equal measure. So let's just kind of tie in with what we did above. So if we take the measure of angle 1, and that equals the measure of angle A, and we're going to take the measure of angle 3 and set that equal to the measure of angle C. Okay, and that's really just what we've got above. We're just putting the measure part of it back in there. And then now we have the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180. Now why is that? Now, so now we're tying back 5 and 8 together. So these two here, in the wrong button, 5 and 8 are being tied together. So why is that? And that last property is going to be substitution. Okay, I know this one was tricky. It was long. It's a little different because we're tying in angles with letters and numbers, but I hope you did well, and then you've got some practice in your homework also. All right, let's go on. So we've got a couple more examples. All right, number 6, solve for x, y, and z in the figure below. So we've got a lot going on here, and so let's see what we know here. So I would say, looking at all my triangles here, I would probably find x first. So let's find x. Okay, so let's find this x right here. So that's what I'm going to plug in right there. Well, what do I know about that x? Based on our triangle sum theorem, I know that x, oh, I lost my values, x plus 46 plus 32 equals 180. Okay, so if I add those up, I get x, and so I'm adding these guys right here. And that adds up to be, is that 78 plus 78, and that's going to equal 180. Okay, let me fix that. There we go. Okay, if I subtract 78 on both sides, I get x equals 102. Okay? All right, so what I do is I go ahead and I map these out as I get them, as I get my answers. So go ahead and do that, and go ahead and label your triangle right there and put 102 in there. Okay, so now we can see that that right triangle is all filled out. So now we need to look at the left triangle. So what, in purple, what's the next thing we're going to do? So looking at the other triangle, what would be the easiest thing to find? Okay, I hope you said we're going to find y, because y is right next to x, and we know that x and y are a linear pair. So because they're a linear pair, they're going to add up to 180 degrees. So let's do that. So we have y plus x equals 180 degrees. And we know that x is 102, so I'm going to substitute in 102 for x, and then that equals 180. So if I subtract 102 on both sides, we get y is 78. Okay, so I'm going to label my triangle here and put 78. All right. What's the last thing we're going to find here? Now we've got z is the only thing left, and to find z, what do we know? Well, that left triangle adds up to 180 degrees. Okay, so I'm going to have z plus 78, that was my y value, and my top angle is 36, and all that equals 180. Well, when I add these guys together right here, kind of a funky 36, I get 10, 11, 114, sorry, equals 180. All right, subtract 114 on both sides, whoops, and I get z equals 66. Okay, and then so I'm going to put this in right there. All right, now looking at the big picture again, there's always a way in math, or typically there's a way that we can check our answer. So I found the 3 angles that I needed to find, but you could always check your answer. Now take a look at this big picture here. Get out of here. So take a look at this whole big triangle here. All right, so what do we know about that? We know that this little guy here, oops, is 66. We know that this was 46, and that was given originally. And then remember, these 2 angles right here were originally 36 and 22. So what is that? 58 total. So if we check that, 58 plus 66 plus 46, does that equal 180 degrees? And if it does, then you've got it right. So 60 8, let's see, I made an error here somewhere. 66, 56. Did I copy one of them down? Oh, I put 22 instead of 32. That's what I did here. So this is a 32. And so this is 68, and this is 68. There we go. All right, so now when we add that up, we get 180 equals 180, and it checks. For our next example, number 7, we're going to talk about exterior angles of a polygon. And so we can draw an exterior angle from any triangle. And in this case, we're going to name that exterior angle, angle 1. Well, the two remote interior angles in green are 2 and 3. So take a look at these 3 pictures here and notice kind of their shapes or what they look like. Mark this one. Oops. 1 also. Okay. So what ends up happening is this. All right. On the next page, we have theorem, triangle exterior angle theorem. And we have angle 1 is going to be equal to angle 2 and angle 3. So what we're going to do is we're going to add these two together, and it's going to equal our angle, whoops, wrong one, our angle 1 right here. Except I did it in the wrong color. There we go. Okay, so angle 1 is here, and then the two interior angles that are far away from that, the sum of those are going to equal angle 1. So this is going to be pretty nice, and so we're going to be able to find some measures because of this. So I'll do the first one for you, and then I'm going to have you guys do the next ones on your own. And then you can see the answers. All right, so number 1, or example 9, it says, what is the measure of angle 1? Well, we know that the measure of angle 1 is going to equal these two angles added together. So we're going to take 46 and 41. Well, 46 and 41, what is that? 87. So we have the measure of angle 1 equals 87. And we're done. Not too bad. Okay, so take a look at number 10 and 11 and do those on your own. And then we'll come back and I'll show you the answers. Pause the video. Okay, how did you do? On number 10 and 11, both of these, the angles that were missing were not the outside angles. So you had to kind of set it up, and then for example, for number 10, 119 equals 53 plus the measure of angle 2. And so you want to make sure you're putting your values in the right spot. Okay? Let me know if you have any questions on these last two. I'll answer them in class. Otherwise, your homework is on page 175, but follow your assignment guide. Thank you.